To support users in finding an optimal clustering solution, we propose XplainableClusterExplorer, an interactive and explorative approach suitable for feature selection for clustering. XplainableClusterExplorer is implemented in R with Shiny and Plotly. In an interplay of user with both an unsupervised and a supervised machine learning model, feature subsets and model hyperparameters are determined in order to yield a clustering that is meaningful for a given problem setting. Especially for clustering, an efficient feature selection is necessary by selecting a subset of important features. Here, the challenge is to determine features that maximally enhance the clustering performance and to remove irrelevant features. Our approach contains two essential steps, supported by extensive interactive visualizations and evaluation criteria. In the interactive cluster exploration step, the user seeks to find an optimal clustering. Additionally, we transfer the successfully applied feature selection in supervised machine learning based on feature importances to clustering methods. In the model-based feature exploration step, the identified clusters are used as tentative classes in a subsequent classification step, and feature importances are automatically calculated. Based on these insights, the user can adjust the current clustering settings. With the following walkthrough of our approach, we seek to illustrate the utility of the interaction of both steps of XplainableClusterExplorer in order to find the optimal hyperparameters and feature subset that leads to the best clustering. As dataset, we used an artificially created dataset containing 4 clusters with 400 data instances and 10 features. As unsupervised machine learning model, the k-means algorithm is used, while as supervised machine learning model, we utilize the random forests method. First, we will save the current cluster settings in the implemented history in order to compare these afterwards with the optimal solution. The done index and evaluation criteria for clustering is 0.145 for the current clustering settings. From a user's point of view, determining the optimal number of clusters is an essential step as this highly influences the clustering outcome. In finding the optimal number of clusters, XplainableClusterExplorer supports the user by means of the elbow method plot here and the Zeret method plot here. For the initial feature selection containing all features, the Zeret method plot highlights the optimal number of clusters to be 10. But according to the elbow method plot and the corresponding biggest band here, the optimal number of clusters seems to be 6. Let's initially set the number of clusters to 6. Now, we want to deselect non-informative and redundant features and find an optimal feature subset. For this, we begin with investigating the correlogram. In this case, we cannot extract insights regarding correlative features suitable for deselecting due to the absence of highly correlating features within this dataset. But a further powerful plot for deselecting features is the parallel coordinates plot. Here, we clearly see that the features F4, F5, and F6 separate the data instances much better than the remaining features, which we'll deselect now for this reason. This leads to an immediate adjustment of the visualizations and evaluation parameters. Now, let's switch to the model-based feature exploration pane in order to investigate the feature importances for the current clustering settings. First, let's have a look on the classification results and the performance indicators of the supervised machine learning model in order to ensure the calculated feature importances are valid. The accuracy, sensitivity, and specificity is 100%. And there are no misclassifications. And according to the random forest feature importance, feature F4 and F6 tends to be more important for an accurate classification of the data instances than F4. Based on these insights, we will deselect F4. For a more detailed feature importances analysis, the user can make use of line feature importance, a novel model interpretability package suitable to investigate the model's most important features for the classification of specific data instances of the test set. Now, after deselecting feature F5, let's switch back to the interactive cluster exploration pane. The deselection of feature F5 leads to an adjustment of the proposal of the optimal number of clusters within the dataset. Both the elbow method plot and the Surette method plot recommends us to set the number of clusters to 4. By additionally taking the done index plot into consideration, for the current feature subset containing F4 and F6, the done index with 4 clusters is significantly higher than for the remaining number of clusters in the range from 2 to 10 clusters. Based on these evaluation criteria, we set the number of clusters to 4. This leads to the best done index achieved so far with 1.58. Finally, by having a look on the 2D plot, it's clearly visible that with the determined feature subset, the data instances are very well separable into 4 clusters, and we find the optimal clustering settings according to the done index. At the end, again, let's save the clustering settings in the history. This allows us to easily reproduce the clustering, especially meaningful and necessary when complexity increases in case of high-dimensional data. Furthermore, this ensures the possibility to systematically sample and compare different clustering settings. This was the walkthrough of our Explainable Cluster Explorer, an interactive and explorative approach suitable for feature selection for clustering.